This is our 37th lesson, looking at problems during the field reversal. What problems would occur during a reversal of the magnetic field? Now, Stephen Jay Gould wrote about this. He wrote about how the magnetic field affects certain living organisms. Certain bacteria, insects, birds, and fish seem to use miniature magnetic compass needles made of magnetite and biologically generated and localized magnetite crystals been found in a variety of other magnetically sensitive species. So he lists a number of things: bacteria, insects, birds, fish, and other animals. And he says, on the other hand, some marine invertebrates, that would be sharks and rays, manta rays, and things like that, detect the stingrays, detect the Earth's field inductively, which means as they move through the magnetic field, it creates a voltage in their system and affects their system, and by swimming through field lines. That's called electromagnetic induction. Now, Atkinson wrote, orientation using information from the geomagnetic field was first discovered in birds more than 2 decades ago. Since then, a large number of reports have revealed that magnetic compass sense is widespread among birds and other animals. Now, this was written several years ago. This has really exploded, and there's more and more information regarding that. So what we have is a number of animals use the magnetic field to migrate or navigate. The honeybees, for example, when honeybees navigate and build honeycombs, they use their bodies as tiny compasses guided by the Earth's magnetic field. Honeybees, Apis mellifera, are among the many organisms that can sense the Earth's magnetic field through magnetoreceptor cells. So there's a number of organisms, and they keep discovering more and more. Termites also use the magnetic field of the Earth to move through their tunnels. According to New Scientist, page 1976, page 391. While this might even be one way to kill termites, confuse them with the magnetic field in the foundation or stem wall of a house, and a magnetic field that can be changed. The direction can be changed from time to time through a magnetic induction. And that would be very interesting. You could flip the field and then change the direction, and these drive these termites crazy. They can't find their way through their tunnels. Let them die. Might be that simple. Turtles, this was sea turtles, seem to carry a remarkable sophisticated magnetic compass in their heads. Now, the turtles in aquatic environments, that is freshwater environments like lakes and streams, may also do this. I have no evidence that they do. But the compass lets them use the Earth's magnetic field to tell one direction from another. More importantly, the compass enables them to sense how far north or south they've come, according to Secrets, pages 661 and following. Now, furthermore, we see this interesting. Sensitivity to the Earth's magnetic field plays an important part in many aspects of vertebrate. That's animals with vertebrate orientation. Recent neurophysiological evidence suggests that the magnetic compass in vertebrates is linked to the visual system. So somehow it changes their vision, according to Phillips and Borland. Frankel lists a number of other organisms that are either oriented with or navigate by the magnetic field of the Earth. Here's a link. This is a fox using the magnetic field to find its prey. And you can do a search on this, and you can find a whole bunch more information about other organisms that use the magnetic field. This actually shows one hunting. And when they line up with the magnetic field properly, and they almost always do, then they get their prey. If they're not lined up correctly with the magnetic field, frequently they miss. And this is diving into the snow to catch a mouse that's under the snow that they can hear. That's very interesting. But here's a link to it. And you can do a Google search for this kind of information and get more information. Back to Seacrest, they're experimenting with sea turtles, a magnetic coil system that would create a field around the swimming turtles. That's in a tank that they were in. They put this magnetic field. He started the turtles off east. They were traveling east. Then Lohmann rocked their world, turning on the coils and reversing the field so that it flowed from north to south. Sure enough, the turtles reversed too. They changed direction. They stopped swimming east and began swimming towards the new magnetic east, which, since the field was reversed, was really west. So these turtles that would normally were swimming east, they began to swim the opposite direction when the field was reversed. Obviously, they were following the field. Another factor associated with the field reversal, which would cause extinction of organisms, is the period of time that the field was zero or near zero would allow extensive amounts of cosmic radiation to bombard the Earth. Now let's go back to summarize these points with these animals. These animals migrate or navigate from their nest or navigate through the tunnels by means of the magnetic field of the Earth. And if the magnetic field disappeared, they can't find their way through their tunnels. The bees can't find their way back to their hives. And if they're using that means to navigate, we will see later that a number of birds actually migrate using the magnetic field of the Earth. Now, here's another factor that we want to realize or note. If we lose the magnetic field protects us from cosmic radiation. Now, cosmic radiation is usually the nuclei of atoms. Most of them will be small atoms, such as hydrogen, helium, but something small, maybe even up to carbon. But these atoms then are moving at high rates of speed. And when they come through the atmosphere, they do damage to cells. They damage cells. They cause mutations. There are high energy nuclei of atoms coming from either the sun or other stars. Remember, our sun is the nearest star to us, and it is a star. And these cosmic rays create radioactive isotopes. Now, if you haven't studied nuclear physics, isos is the word same. And so an isotope is the same element, but it just has different number of neutrons in the nucleus. That's all it is. We'll talk about these later when we get to radiocarbon dating. And cosmic rays create radioactive isotopes in the atmosphere. Now, what this does, these radioactive isotopes, which lead to 3 radiation hazards. Radioisotopes contribute to the background radiation. If you take a Geiger counter and put it on just look at your desk, you'll find that your desk is radioactive. Put it on a spoon and you find out the spoon's radioactive. This is called a background radiation. There's radioactive material in most everything around us. Now, this radiation is no amount of nuclear radiation is good for you. Now, you say, well, don't they use it to kill cancer cells? Yes, but it's killing certain cells. The cells are vulnerable when they're in the process of splitting or dividing. And so it gets the cancer cells, many of them when they're splitting, but it also destroys some good cells in the process. So it's a matter of do you want to take some damage and get rid of the cancer, or do you want to leave the cancer? And so that's what happens. Radioactive isotopes contribute to that background radiation, which is not good for us. And he said ingested radioisotopes, when you eat them, such as that might be in your food, or you breathe them or drink them in water, give an internal radiation dose. radioisotopes incorporated into the genes, if they get into the genes of your body, may destroy the gene from the violence of their decay. When they decay, they change and give off a lot of energy when they split, and that can damage that gene. And of course, if the gene is damaged, it may pass that on. You may pass that on to your offspring. Now, take me at my age. I'm not going to have any more children, so I wouldn't pass it on to my offspring. But it would damage my body, however. At a polarity reversal, now Black says this. He's talking about a polarity reversal of the Earth's magnetic field. The production rate, the concentration and hazard of these isotopes will increase. So what happens is he's telling us that if it reverses, at that reversal, we'll have a lot more of these radioactive isotopes, radioisotopes they call them, and they're all damaging and they'll cause genetic problems. And so we get mutations to be set in. I don't really know of any mutations that are beneficial. They may be beneficial in a limited sense, but such as we may see someone with sickle cell in their blood, sickle cell, and they are a little more resistant to malaria. But that helps them there. But the sickle cell is definitely detrimental in most other ways to them. The atheist admits that he has no mechanism for his field reversal hypothesis. Now, again, the fact that they can't tell how it happened doesn't mean it doesn't happen. I want you to understand that. But they demand of Christians that we explain every single thing, give an explanation for it, but they are not capable of giving explanations for their hypotheses. Gallet and Vallet, the brief periods of a few thousand years of switch between the two party states are called reversals. Reason for reversals are still unknown. In other words, they admit they don't have any way to explain why these would reverse. It's apparent that anomalous, Muckle and Burton say, anomalous magnetization doesn't follow the rules, normal, can be produced in hydrocarbon seepage environments, chemically and bacterially. Now, I want to stop here just a minute. What we mean by hydrocarbon, that's oil, and usually it's oil. Hydrocarbon could be natural gas as well, but seepage is oil. There is oil seeping out from the earth itself, and it's seeping out into the oceans and the bottom of the oceans. And this hydrocarbon then seeps up, and he says that anomalous magnetization is produced. It magnetizes, and there's several reasons why it will do that. But anomalous magnetization may be positive, absent, or negative relative to the total magnetization of surrounding rocks. So with hydrocarbon out there, it could actually be backwards, and it can give you anomalous magnetization. Hydrocarbon can. Sometimes this hydrocarbon is misinterpreted as ships polluting the ocean. Keep that in mind. Now here's an unsound argument, and it commits the logical fallacy of denying the antecedent, which is a fallacious reasoning. If Fox, that's me, can explain the anomalous magnetic fields, then there's an explanation. Well, that's certainly true. That's certainly true. And then they say Fox cannot explain the anomalous magnetic fields. That may or may not be true. But let's assume it's not true. That doesn't prove that there is no explanation. You might not be able to explain how a hydrogen bomb works, but I'll tell you it works. And the fact that you can't explain how it works doesn't mean it doesn't work. In 1971, I had a fellowship to study lasers, and we built a laser. Prior to this time, I didn't know how a laser worked. And but lasers were being used. They'd been invented about 8 or 10 years before that. So what we run into is just because you can't explain how something works doesn't mean it doesn't work. You might not be able to explain how a laser works, but you may have had one used on your eye to help to work on your eyes with, or to be used to do other things. You probably have used lasers, didn't even realize you were using them. So the fact that you can't explain a laser doesn't mean it doesn't work. And only this would work with God. However, if God can't explain something, then there's no explanation, because God's omniscient. He's all-knowing. But this argument here on a finite human being just is not sound. It's logically unsound. Now look at the following slides, and I want you to notice them for one explanation of the causes of apparent field reversal. We've been through this already. The planet that brought about the flood, and I'm convinced it was Mercury, came in above the ecliptic plane. Remember, the ecliptic plane is an imaginary line from the center of the sun to the center of the Earth. And so this planet came in above the ecliptic plane, several degrees above it, crossed across, made 3 passes around the Earth. Each time it moved closer to the ecliptic plane because of the gravity of the sun. And this planet then was pulled off by the planet Mercury. Now, when it did this, as it came in, it had rings around it, and as it circled around the Earth, its magnetic field, it also had a magnetic field, interacted with the Earth's magnetic field. So what happens here is the magnetic field, the North Pole on it, for example, would go up through the Earth itself. Magnetic field moves up through. This is magnetizing rocks that maybe have been formed due to volcanic activity, or it's plate tectonics creating gaps where magma comes out of the core of the Earth. And so the magma will have iron and nickel and cobalt in it, which are magnetic materials. So that's what we have here, and that was one possible explanation. So this magnetic field, if the north, remember the north geographic pole is the south magnetic pole on the Earth. And so if we have it like this, the poles would have to move around and go in this fashion. So it would get us a very interesting arrangement as it moves to the Earth itself, this magnetic field. That's a possible explanation of part of the material of the things that we actually see. It's necessary to admit in the first place, just a quote now, that at the present time there is no satisfactory explanation of the modus operandi of displacement of the lithosphere. Now the lithos is the Greek word for rock or stone, and of course the sphere is a circular object. So what we have here is he's talking about the rocky part of the Earth that is the crust of the Earth. The purpose of this book, that's a quote now, the purpose of this book is simply to present the case for the assumption that such shifts have occurred and to show how the assumption explains numerous unsolved problems in geology and in the evolution of life. Now, this fellow is not a believer in God, but I want you to notice here, he's saying, I'm using this argument to show the assumption to solve some of the problems of geology. And of course, evolution, which I don't believe occurs. In addition, now this is Hapgood. Remember, his book is endorsed by Albert Einstein. In addition, I present evidence dating the last 3 displacements. So he talks about 3 displacements of the lithosphere. That's displacement of the crust of the Earth, and placing them in the latter part of the last geologic epoch. That's Hapgood, pages 40 through 41. Note that Hapgood discusses the last 3 displacements. My flood model postulates 3 passes of the planet Mercury during the year of the flood. And we can get 3 basic displacements occurring during this time. Let's go further on this now. the geographic pole has been wandering. It's been moving. There's evidence of that. They can measure it and see that it moves. Let us visualize briefly the effects of the displacement of the lithosphere. Here we will simply point to the fact that the oblateness of the Earth, oblateness means it's not a perfect circle or sphere. It swells and is thicker at the equator than it is at the poles. That's what we mean by oblateness of the Earth. We already talked about that in the prior lesson. It involves the consequence that in any displacement of the lithosphere, parts of the Earth's surface will be under compression and other under extension. So they'll compress, others will extend or stretch out. This is because such a movement will displace some areas toward the poles and others toward the equator. So remember, it's swelling, it's thicker at the equator than it is at the pole, due to the spinning motion of the planet. And so that's what you're looking at when you're looking at oblateness. Areas move poleward toward the poles will be under compression, while those move toward the equator will be stretched with consequent widespread fissuring. So they have fissures in them. And the enormous force of moving lithosphere, the lithosphere moving with tremendous force, fantastic amount of momentum, moving lithosphere would produce folding and strata in some areas and fissuring in others. This is exactly what my flood model hypothesizes. That's what happened. Hapgood claims the ice caps caused this phenomenon, that was one factor that caused it. He claims mainly the ice caps, due to the weight of it. Large amounts of cosmic ice, according to him, raining through the windows of heaven. Cosmic ice is what he said. Now, this is not a quote of him, but this is my notes. Through the windows of heaven and deposited in an asymmetrical manner. Now, that means it's not symmetrical. That is, there are some places where there's more ice than others. For instance, Canada and northern Alaska, mainly Canada and Alaska in the northern North American continent, had a lot of ice. There's not near as much ice. It wasn't near as much ice over in Siberia. And Siberia is awful cold as well. So the ice was deposited more with regard or around the magnetic field. That's very interesting. Now, our hypothesis on this is ice particles followed the magnetic fields into the atmosphere. Now, he said it's deposited in an asymmetrical manner with respect to the geographic poles on the polar regions, but upset the angular momentum of the Earth and cause it to wobble on its axis like an automobile tire that's out of balance. If you ever had a tire on your car that's out of balance, you get a little bump, 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 you'll see it, and it shakes your car. And that happens, that's angular momentum. Hapgood develops the mathematics of the physics involved in these processes. But he does talk about cosmic ice changing the Earth's angular momentum, affecting it. Now, let's use the New American Standard Version and see how it translates a passage referring to the flood, Psalm 104, verses 5 and following. He established the earth upon its foundations so that it will not totter forever and ever. Notice the word totter. Thou didst cover it with the deep as with a garment. The waters were standing above the mountains. At thy rebuke they fled. At the sound of thy thunder they hurried away. Now, this is a reference to the flood. We've already talked about that. The mountains rose, the valleys sank down to the place which thou didst establish for them. Thou didst set a boundary that they may not pass over, that they may not return to cover the earth. So this is a reference to the flood. But he talks about tottering. Let's go back and see that word totter. It's underlined in verse 5 there. Now, if the basic premise of this book is correct, the changes in angular momentum of the earth by both the deposition of ice, the ice caps, and the melting of the ice caps would cause the geographic poles to wander. Just like a tire, an automobile tire would be out of balance. In addition, the impacts of bolides, that's objects coming with, probably mostly from the rings, but it could be particles that were lofted up due to impact from Mercury, and the Earth's gravity pulled them into the Earth. But mostly this probably would be particles from the rings. The bolides on the Earth would cause gravitational anomalies on the Earth. So there'd be places that the gravity would be stronger, maybe due to these dense materials. But again, that will make it like a wheel wobbling, and it'll make it be like a wheel out of balance. Gravitational anomalies would affect the angular momentum of the Earth as well, and change the movement. Now, we had volcanoes during the flood. Evidence of that is clay layers, apparently of volcanic origin, occur throughout the latest Permian Changxing formation, and a particularly thick clay marks the basal Triassic. So what we have here is we have evidence of volcanic action in the sedimentary rock that was laid during the flood. But there's no problem. My model would explain how we'd get volcanic action occurring. This provides evidence of volcanic activities during the flood, of course. Now, what we have is sulfide, sources of sulfide, that's the sulfur derivative, to the core side, and core down include a combination of volcanic activity, the core drill down into the Earth, marine biogenic sources, so marine life, that's things out of the ocean, and evaporate sources. We're going to explain how evaporate sources would occur during the flood as well. We'll get to that later. Prominent volcanic events may be represented by some of the residuals in the series, but the overall importance of volcanic source sulfate is less than other sources in the recent record. So we do have abundant evidence of volcanic activity, along with the deposition of marine fossils. And this, of course, occurred during the flood. Notice further. Let's go to the Oblateness now. Now, my hypothesis would be that volcanoes occurred and objects struck the Earth and ice was deposited. And for a brief time, we had water coming out of the oceans covering the land. This, of course, changes the isostasy as well as the ice water load changing the isostasy of the continents. And so it's like if you put weight into a boat, it'll sink deeper into the water, and the water then is pushed aside. Oblateness, we've already talked about, is the measure of the bulge at the equator of a spheroid. It's usually used to express the measure of a bulge of an astronomical body. That's what it's usually used for. Oblateness of 0 means the polar and equatorial radii are equal. So it's a perfect sphere. That would be an oblateness of 0. If you went to the other extreme, an oblateness of 1 means the object is a disk with a thickness of 0. Of course, we can't have that, but a very, very thin disk will get close to 0, get close to 1 for oblateness. And it will approach an oblateness of 1. Here's your formula for oblateness. OB, oblateness, is equal to the radii of the equatorial radius of the equator, minus the radius of the pole. So on the Earth, it would be from the equator all the way through, halfway through at the equator. And R sub P over here would be the halfway through the Earth, from the center of the Earth to the poles, to either of the poles. And so it's RE, R sub E minus R sub P over the quantity R sub E. That's your simple formula for it. Yeah. Here's a picture of a spheroid. It's the way it's drawn here. This dimension here is thicker than the dimension through it. It's drawn that way. Of course, Saturn is a if you had a big enough ocean, Saturn would float in it because Saturn is less dense than water. But because it's not very dense, it spins at a high rate of speed, and this creates a bulge at the equator. So it has a pretty good amount of oblateness. Here are all the planets, and I've included Pluto, but the oblateness of Mercury and Venus is considered to be 0, which means it's a perfect sphere, or close to it. They don't rotate very rapidly, so they don't have a lot of oblateness. The Earth's oblateness is 0.004. It rotates at a rotation rate of 24 hours in this day. Now, Mars has an oblateness of 0.009, and it has 24.6 hours of speed in its rotation. That's an interesting arrangement. They're pretty close to the same value. And some have theorized that they interacted at some time in the past. That's a possibility. Jupiter, and it spends 10 hours, its day is only 10 hours long. So it's spinning faster, more than twice as fast in rotational speed as the Earth. And it's 0.06 for its oblateness. Saturn spins at 10.7, but it's made of less dense materials. So it has an oblateness of 0.1. That's quite a lot, pretty thick at the equator compared to the poles. Uranus has the same oblateness as Jupiter, and it rotates retrograde. It rotates backwards, and it's 0.06. Neptune is 0.02. It rotates on a 16-hour day, 16 hours on its day. Pluto, oblateness is unknown, and it's 6.4 days on its rotational period. So this is our table for the planets if you include Pluto. When I made this out, Pluto was still considered to be a planet. And so it's all in the definition anyhow, so I'm not going to worry about it. Let us visualize briefly the effects of the displacement of the lithosphere. Now remember, that's the crust of the Earth. Here we will simply point to the fact that the oblateness of the Earth involves the consequence that in any displacement of the lithosphere, parts of the Earth's surface will be under compression and other under extension. Extension means just to be stretched out. This is because such a movement will displace some areas toward the poles and others toward the equator. They'll move in different directions. So that's what will happen. And this is, again, we're back to Hapgood. This is Hapgood continuing. Areas moving poleward will be under compression, while those moving toward the equator will be stretched with consequent widespread fissuring. The enormous force of the moving lithosphere would produce folding and strata in some areas and fissuring in others. The oblateness of the planet is inversely proportional to the period of rotation. That is, the faster it rotates, the more oblate it is, generally speaking. Of course, there has to be the material from which it's made has to be factored in as well. Oblateness of a planet generally increases with the speed of the rotation on its axis, generally does. Rigidity of the material, now, of course, what we have is Saturn is made up mostly of light gases, hydrogen and helium, primarily. Some other gases, but to a large extent, it's very light. It's not very dense. The material isn't. Of course, its gravity may make it denser. It does, but it's by and large not very dense. The rigidity of the material in which the planet is composed also affects the oblateness. Right? Again, we go back to our table, which we've already seen. We'll look at it again. Astronomers generally classify the four inner planets, Mercury, Venus, and Earth, as terrestrial. That's Earth-like planets. Astronomers generally classify the next four planets, Jupiter, Saturn, Uranus, and Neptune, as Jovian or Jupiter-like planets. These are generally thought to be, the best we can tell, they are gases that have been compressed gases to a large extent. tiny Pluto is probably more Earth-like than Jupiter-like. So it's not very big, but it's more like the Earth. It's more like a rock or a solid type material like the Earth is made up of the moon. Now our forces rotate in a tangential way. This is a tangent, straight line, and it would be perpendicular to the radius of the object, of the spinning, rotating object, in this case, a sphere, a ball. Spinning motion of the planet causes an uplift on the crust of the rotating surface at the equator, assuming the equator is perpendicular to the axis of rotation. The real force is in the direction of the tangent line. Let's go back and see the tangent line. That's this line here. That's called the tangent line. Uplifting force is a vector force, and this gets into some trigonometry obtained from this tangential force. Now, Sonnet and et al. And others claim the length of the day on the Earth was lengthened from about 18 hours to our present value, 24 hours. And we'll be talking about that and looking at that in the future just a little bit more. But there seems to be some evidence that prior to the flood, the day was quicker. The Earth spun at a faster rate. And this could easily be explained by the planet Mercury coming in, and transfer of angular momentum could have slowed the Earth down, and in the process, it would have speeded up the planet Mercury and flung it away from the Earth. Yeah, it's entirely possible. That's the exchange of angular momentum. They extrapolated the present rate backwards. That's the present rate of the moon moving away from the Earth. And of course, they're using linear extrapolation, which of course they're using then the assumption of linear operations. The causes and effects are linear. And that's uniformitarianism, of course, which they've rejected. When the contribution to tidal friction from the sun is taken into account, these data imply the length of the terrestrial day 900 million years ago was approximately 18 hours, according to these fellows, okay, Sonnet, okay, 18 hours. Another source of this, to try to figure out how many days there were in the year. If the Earth has its same period around the sun as far as time, but it's rotating faster on its axis, then the year might have more than 365 days in it if the Earth rotates faster. Now, a man named Wells began looking for diurnal lines, this is daily lines, on fossil corals. He found several Devonian and Pennsylvanian corals that do show both annual and daily growth patterns. He was astonished to find the Pennsylvanian forms had an average of 387 daily growth lines per year cycle, and that the Devonian corals had about 400 growth lines. So again, he's claiming the day as the Earth has slowed down on its rotation on its axis over these periods of time that the atheist postulates. Counting between annual marks, Wells found an average of 360 growth lines per year on modern coral. Then he constructed a graph based on the latest isotopic datings of the periods back to the beginning of Cambrian. Now, what's that mean? He's looking at the isotopes in it, and probably looking at radioisotopes. And the graph suggests a systematic decrease in the number of days per year through the geologic time. Now, again, he's doing this dating by radiocarbon or radiometric dating, not necessarily radiocarbon, but other materials. Radiocarbon won't reach back more than about 100,000 years. We'll talk about that later. In 1968, Pinella and his associates, using many more organisms from recent Cambrian, showed that while a systematic decrease is probably valid, their graph formed an S-curve rather than a straight line. I want you to notice this. It's formed an S-curve instead of a straight line. Now, they used linear extrapolation on a curve that wasn't linear. The S-curve probably caused by the different effects of tidal action, accompanying the changes of continents, observations, and epieric seas. Now, an epieric sea is a sea that is upon the land. So it's a sea that's covered the land for some period of time. Okay, that's what that is upon. We should note that Don and Prothero, probably geologists, not very mathematically literate, graph is an S-curve, which proves that linear extrapolation is invalid. You can't use linear extrapolation on a curve, on a curved line. Now you can use another form of extrapolation, but it won't be linear. And so that's one of the problems with it. He's used linear extrapolation, and he's come up with, and he's got a curve for his whole system. So his whole system is flawed. The writings of these men who claim the length of the day has changed, it appears that they have employed linear extrapolation on the data, and the data follows a nonlinear curve. Now, let me go on with them. For counting the maximum number of ridges laid down, it's obviously most useful to study those corals which have led the least disturbed life, or that have been modified the direction of growth in a constant direction. Scruton goes on, the possibility must also be borne in mind that these fine growth ridges are diurnal, that is recurring every day, as it is claimed. Unusual circumstances may have caused an increment to be missing for several days, or conversely, two increments be deposited in the same day. So there's unusual circumstances that could have caused that. Now, here's the thing. If the planet was riddled by the tidal action, and tides kind of cause the growth ridges on the coral, then that could mess up all of this during the flood year, the year of the flood, 150 days of the flood. Could give us tides, many more tides than normal. So we could have changes that would upset the apple cart. There may be other factors that will change it as well, and got to keep that in mind. In addition to the more or less erratic changes that affect the Earth's rotation, there's substantial evidence that the day is gradually getting longer. Well, it is getting longer now due to the moon's change of angular momentum with the moon. This lengthening is due to the gravitational pull of the moon on Earth's tides, which are steadily slowing the rate of rotation. That's due to the exchange of angular momentum. That's what he's talking about there. In addition to the good theoretical reason for suspecting this variation, there's a fossil evidence the year has been 400 days in the Devonian period, about 400 million years ago. This is arrived at by counting minute growth rings in fossil corals. Each ring supposedly represents a day's growth. That's assumption. The space of a year can be determined by noting seasonal variation in the size of the growth rings. So they look at the various sizes. Again, they're assuming various seasons that cause the growth rings. And so they look at the size of the growth rings and count the years by them. Again, it's a little bit subjective. Studies of growth bands in bivalve shells and corals have succeeded in proving that the number of days in a year has decreased from about 400 in the Devonian times. Furthermore, the lunar month in the Devonian was 30.6 days long compared to 29.5 days at present. So again, the lunar month has changed according to them. They assume, however, the position of the Earth in space has not changed. Okay? Position of Earth in space can be checked by reference to other astronomical bodies, and the period of revolution has been found to be invariable during the period of instrumental observation. So while we've been observing it, we can't see any variation in it. But they postulate this is 4 or 5, nearly 5 billion years, at least 4, that this has gone on. And they're looking at a segment of time for a couple of hundred years that they've been observing, just a few hundred years. That's a minute amount compared to 4 billion years. So it's a very small fraction of it. Not a very good sample to look at. What Stokes is saying is the Earth is not presently changing its orbital distance from the sun. Best we can tell. From this, he concluded it has not moved in the past. That's an assumption. Past is not necessarily, present is not necessarily an indication of what has happened in the past. When dealing with fossils, however, difficulties arise. Now, this is another source. How do we know? Well, poor preservation of the fossil, ambiguity of growth patterns, they might be ambiguous, might not be able to find them quite well, lack of modern representatives. That is, we don't have any modern representatives of these fossils, make the counts of growth increments highly subjective. This is one scientist claiming that's too subjective. In general, growth patterns record fewer increments in actual days. That's what they say. Gaps in the record, which are randomly controlled by the environment. So there's random things in the environment that control this, affect the degree of precision on the information, since there's no way to establish a ratio from each specimen. So again, we have a problem with it. The gaps in the record, there are gaps, are randomly controlled by the environment. And they affect the degree of precision of information, since there's no way to establish a ratio for each specimen. We don't know how precise our readings are. So again, we have a lack of precision in our measurements. The degree of resolution required by geophysics is higher than the precision obtainable from the paleontological clock. So we need resolution. That means, can you discern between one line and another line? And that's your resolution. And so he says it's higher, the resolution required is higher than the precision obtainable. So you cannot obtain enough precision in your measurements to get the proper resolution. And he says, based upon the few data so far gathered, so there's, what we find is, sounds like it's pretty subjective. It was found impossible to recognize yearly annulations on the material examined, according to scrutiny. We couldn't recognize yearly annulations on the material examined. So we have to just theorize that this is an annual ring. The only long-term study on the time scale of millions of years is Wells. Wells is paleontological study on daily and annual banding of corals, result of which suggests a much slower lunar recession than nautiloid data. So we have nautiloid shells, and their data is contradictory. It doesn't agree with it. Although the existence of annual banding on corals is well established, there's some question about daily banding in modern corals. That's Kahn and Pompeia. So again, the modern corals, there's a question about daily banding in them. Catastrophic events of Genesis 6 through 9 would make the extrapolation of the present rate of the increase of the length of the day from determining the age of the Earth to be incorrect. Notice they're using linear extrapolation. My hypothesis is that the speed of the Earth's rotation was slowed down over that period of 150 days, creating all kinds of havoc, raising mountain ranges and other things. Linear extrapolation assumes the variables are rated in a linear manner over long periods of time. That is uniformitarianism. Again, we have them using uniformitarian assumptions in their interpretation of what they find. Linear extrapolation data is only correct when the variables are related in a linear manner. So you can't use linear extrapolation if the variables are not related in a linear manner. Now, slowing of the Earth's rotational speed is caused by tidal friction, according to Wolfson and Paskov. It's a university level physics book. And by tidal forces, but tidal forces bearing the momentum inverse to proportional to the cube of the distance. Now, between the astronomical bodies. Now, understand this. What we have here is Wolfson and Paskov tell us that this is inversely proportional to the cube of the distance. But yet they've been using linear extrapolation in this data. Very interesting. And of course, that's a gross assumption, a wrong assumption. Now, here's the problem with it. The geologists using this may not have any background or an appreciable background in mathematics. If you look at a curriculum for getting a geology degree, you'll find that they don't have to have a lot of mathematics. Any change in the oblateness of the Earth would create stresses on the crust of the Earth and cause earthquakes. And this would occur because the change in isostasis would occur as the rotation slowed. So it's going to slow and change the isostasis. The equator would tend to sink into the magma and uplift other regions of the crust. So as it slows down, the equator sinks in and pushes, causes other areas of the crust to elevate. This is due to the hydraulic forces, Pascal's principles. Now here's your formula. This is read as delta C is equal to 2 pi delta R. Now delta means how much it changes. So how much does the circumference change? The change in circumference, length circumference, delta R is the change of the length of the radius. Now this is your formula. Delta C equals 2 pi delta R, the simple formula. The circumference of the Earth would decrease by 6.28 miles, 2 pi actually, for every 1 mile a decrease in the length of the radius. 6.2 kilometers for every 1 kilometer. So we put it in kilometers. It's just a ratio of 6.28 to 1, whatever units you're using. What would happen is the effects of changing the oblateness of the Earth. North-south mountain ranges would possibly be formed by the crust to allow the equatorial radius to decrease. It ripples up. That's one thing that would happen. Second, east-west mountain ranges would possibly form in the crust to allow the polar radius to increase. So it increases. It does this because it has to slow down, and this angular momentum has slowed it down. So it allows the polar radius to increase. East-west mountain ranges will be formed. The Himalaya Mountains, for example. Mountain ranges running east to west or west to east. Third, if plates exist in the crust, and they apparently do, the plates were tilted, and the plate would possibly slide under the edge of another plate. That's certainly good. Plate tectonics theory claims that plates have slid under the edges of other plates. That's the claim. These areas are called subduction zones. We'll have a picture of one in the sketch of one here in just a minute. These areas are called subduction zones by the advocates of plate tectonics. Here's the subduction zone. This is a diagram showing their view of subduction zones. So the material goes underneath the other material, slides underneath it. And then we have, of course, this uplifts this over here and causes a volcanic action to occur. It may even elevate these mountain ranges. Subduction zone, the slab goes underneath the other and goes down, supposedly then begins to melt, gets recycled back up. Down here we have subduction zones down here, the outer and inner core and the mantle up here. Here are the plates, the various convergent plates that we have in the Earth. And these plates, again, as the planet moved around, would pull in this gravity on them, pulling them in different directions. If the planet is over here, like over on the side, and in this region, it would pull these straight toward it. These others would come in this direction. These here would move in this direction. So they wouldn't all be moving in the same direction, moving toward the planet. It would transfer momentum. Its gravity would pull on the plates and move them in different directions. That's exactly what we see. And they would then run into each other. Now, the interaction of the magnetic fields of the Earth and the planet to cause the Earth, these are minor effects. It would cause earthquakes and volcanoes. Magnetic field would cause some forces that would contribute to them. This is how earthquakes and volcanoes are formed. I think the magnetic fields are a minor part of it, not major. The deposition of sediment on the continents, the weight of the sediment would cause earthquakes and volcanoes. The deposition of ice caps that change the angular momentum of the Earth and still change the angular momentum. The ice caps melt and other icebergs or icebergs break off from the ice caps and change affect the Earth and cause volcanoes and earthquakes. Or decrease the rotational speed of the Earth resulting from the tidal action of the flood. If the moon transfers, slows the Earth down due to its tidal action. And Mercury being larger and closer to the Earth would certainly slow the Earth down. So I would argue then that the day before the flood, the period of time for a day before the flood, was probably the neighborhood of what we see now, maybe 18 hours or something like that, 18 to 20 hours. The decrease in rotational speed results from tidal action, and that affected the oblateness of the Earth. It slowed down. It was more oblate before, rotated faster. This created stresses on the crust and caused uplifts and other places where it actually went down into the magma. All of these four factors change the isostasy. That's how it floats in the magma of the Earth, and this constant adjustment of the isostasy creates the forces that cause earthquakes and volcanoes. Again, like a hydraulic jack, the forces would go in all directions. So all of these factors together would contribute to volcanic action. Do you have any questions? Anybody? I realize this is probably a bit boring, but we'll come back to it in just a minute. I'm going to stop recording now.